astronomer, and that is Marley Leacock. Hey, Marley, how's it going?
It's good. How are you?
I am great. It is a very hazy day here on the unceded territory of the Musqueam, Squamish, and Tsleil-Waututh. Of course, our thoughts are out to the people in the Okanagan with all of those wildfires. Hope if you are watching that you are staying safe. For this episode, we are talking about the moon again. Surprise, surprise. But this time we're actually not talking about Artemis. We're not talking about Canada's involvement, not even NASA's involvement. We are talking about another space agency that has landed on the moon, and actually a few countries. So lots to do with the moon today in this episode. If you are out there watching on YouTube land or on Facebook, drop a comment or a question, and we're going to talk about a lot about the moon in this episode. But if you have any questions, even if it's not about the moon, we will answer all of your questions until we get to the half-hour mark. So Marley, it's been the big news of the day yesterday. It's on Google Doodle. I actually have a personal connection with the India Space Agency, the Chandrayaan-2. So back in 2019, when I was still in my role here, I had just come back from the Banff Science Communication workshop. So I was like all jazzed up to be a science communicator. And like literally the day I came back, was when Chandrayaan-2 was going to launch, like the next day, and CBC called me down to their studios, which I thought was very strange, right? Like I hadn't even heard of Chandrayaan-2 when I got the call to come down to the studio to talk about this mission. So I had 2 hours to quickly learn up about it. I called all of my Indian friends and asking them, like, are people in the community talking about this? Like, in Canada, what's the buzz? Like, are people interested in this? And I got a few things here and there. And I talked to Natasha Fatah, who is one of the Canadian hosts of the national CBC. And she, of course, is very invested in this. That's why she wanted to talk about it. So I was actually in studio, and it was a very fun conversation. She was like giving me a hard time because I was so nervous, because there's the bright lights are on you and you're
Oh,
looking at yourself
geez.
on a monitor.
Mm,
And she was making fun of my UFO shirt. And then, of course, Chandrayaan-2 didn't make it. And
no.
then I went back to CBC 2 days later to talk about it. It was very kind of disappointing because, well, we thought we were going to be talking about the success for this smallish agency, and an agency that I hadn't even heard of before. So years later, they announced that they were going to go back again. They weren't going to give up. And they started working on Chandrayaan-3. And here we are. Yesterday, India landed on the moon with Chandrayaan-3. Very exciting day in space for everyone, right? Not just for me that has been learning about this mission for many years now.
No, it was great. Yeah, Chandrayaan-3. Actually, you say small space agency. I'm always hesitant to call it space agency small. I prefer to call
Right.
them young, right? Like this is a,
Yeah.
a very young space agency that hasn't, doesn't necessarily have all the experience and the luxury of time the same way that we think of NASA, right? NASA's been around for a lot longer than a lot of these other space agencies. So it's a young space agency, not small. There's a lot of people who still work there. But Chandrayaan-3, of course, the third one, it's actually very similar to the Chandrayaan-2 mission, right? So it's almost like a copy paste, keep a lot of the same stuff. It consists of a lander and a rover. The lander is called Vikram, which was responsible for the soft landing. That's that boxy shape that you're seeing in the image on the right-hand side. And it has 4 landing thrusters instead of 5. That's a different from Chandrayaan-2. Chandrayaan-2 had 5 landing thrusters. This one only has 4 instead. And inside of the lander is the rover called Pragyan, I might be mispronouncing it, and other scientific instruments. So landers, this is where we get into a bit of what are we sending to the moon terminology. Landers stay in one spot. They don't move, they land, they do all their science in that specific area. Where rovers move around, they're able to go past the lander, explore different things, see different stuff. So this consists of both. The rover is not the hugest rover, but not small either. It weighs about 57 pounds or 26 kilograms. It's got 6 wheels, and its mission is really a tech demo, Chandrayaan-3, right? Chandrayaan-2 was supposed to be the tech demo. Unfortunately, it did crash, so we weren't able to get any of that information. So now a lot of those mission objectives have shifted over to Chandrayaan-3, where we have demonstrating a safe and soft landing on the lunar surface, which they've done successfully as of yesterday, demonstrating rover roving on the moon, which they've done successfully as of today, and conduct in situ scientific experiments. So that's where we get those other scientific instruments on board the lander. A lot of it is specifically looking at the materials of the lunar surface, right? Because we're in an entirely different part of the moon than we've been at before. We haven't explored the South Pole, which is the most exciting thing, I think, about the landing. The fact that it landed, huge fun. But the fact that now India has become the first space agency, the first country to land on an entirely new part of the moon, right? A part that we have yet to explore. The only things we have from the moon are photographs instead from this region.
Very cool. So is this actually connected in any way to NASA and the Artemis mission? Because Artemis will also be going and exploring the South Pole of the moon, or is this just the hot spot that everyone's going to because they're looking for that water deep in those craters?
That's why, so they're not, it's not part of the Artemis program, this mission. This is its own separate mission. India, as a country and as a space agency, has signed on to the Artemis Accords, which are like the governing rules that you have to sign on to be able to benefit from the Artemis program. It's kind of like a collective agreement almost. Like, we're all going to follow these rules. We're all going to play the same game, and we will share science with each other, right? So India has signed on to that, along with, Canada's part of it. The European Space Agency member states are part of it, things like that. But the South Pole, it's really part of the fact that there's water in these craters. And so this is showing kind of where-ish the lander and the rover landed on the moon in the green square. So the green is for Chandrayaan-3. Originally, they were targeting somewhere between Manzinus C crater and Simpelius N crater, like somewhere in here. But I think they're further over. I think it actually landed about in this region, but I'm not sure. I'm bad at reading maps, so I'm not, and I'm not entirely sure where they've ended up.
I mean, it is kind of hard to read a lunar map because it's all the same color and craters all kind of look the same.
They do all kind of look the same. But they're not, there's water on the South Pole of the moon, but it's much more focused in the craters, kind of much more near the pole. Where they've landed, there's not a lot of those permanently shadowed regions. Those are much more clustered right to the pole. So they're not smack on the middle of the South Lunar Pole. They're just in the general area. They're in the general vicinity. It's the most southern we've ever gotten on the moon anyway. So it's still very, very exciting and much more heavily cratered. A lot more going on than we would see perhaps on the near side of the moon where the Apollo missions went. Very much different terrain in different areas. And so a lot of the science being done is really working out what exactly we're dealing with when we get to the South Pole, what's going on with these craters and the regolith and all this stuff on the moon. Or is it more uniform than we think? We don't know. We've never been here before, but still very exciting.
Yeah, certainly this picture of the South Pole is very striking, just how different it is from the normal view of the moon, the near side, which has those flat maria, the darker parts, the contrasts. This very much looks like a foreign world with all of these very deep craters that all seem to be centered around sort of like the pole there. It's very interesting.
It's very interesting. It's also, when you take a circular image, it gets a bit warped. So keep that in mind as well. And it's also not one image. It's several images stitched together. So you get a bit of interesting things happening. But this was taken by, it's actually from a scientific paper or like a scientific investigations map from the Lunar Reconnaissance Orbiter, I do believe. So one of these things that NASA has sent up to like take very detailed photos of the moon. And I didn't really, then scales at the bottom, so you can't really see, but it's very much like 0 to 1,000 kilometers. Like some of these craters are quite large. Like I think Manzinus C was like 25 kilometers across, right? So no big trek going into the crater. The rover won't be doing any of that, but it will be exploring kind of the terrain around it. And its lifetime, which I want to talk about, is only scheduled to be 14 Earth days, right? Which is a very, very short like mission length, right? 14 days though on Earth is the equivalent of one lunar day. Right. So days are a bit different on the moon. So it will be in full sun for 14 days. The sun is less of a problem. It's really the lunar night that becomes an issue. It gets very, very cold. And this rover is solar powered. And so we've seen things happen with previous rovers on the moon. The Chinese Space Agency launched the U2 rover as part of one of their Chang'e missions. And that rover actually ended up suffering a couple of engineering problems due to the lunar night, right? It actually, U-21, I think it stays in one spot and has now not really used anymore because it wasn't able to keep itself warm overnight properly. And a lot of the electronics ended up experiencing colder temperatures than they should have and freezing. And so that's a consideration. I'm hoping that the rover that India has launched makes it through the lunar night. I think it'd be great if it did. I don't know if it's engineered to be able to do that, though. Right. Scheduled to last only the 2 weeks.
Okay, well, looking forward to that and fingers crossed. What else has Chandrayaan-3 taught us?
Well, not much yet. It just started, but it has been sending back some pictures, which I've been able to find a bit of. So the image on the left is from the lander, the horizontal velocity camera. So as it is landing itself, there's all these different cameras that take pictures, but also take in information based on the terrain it's seeing. They just released a video that I wasn't able to get in time to put into the presentation today that show the craft descending. And what it does in real time is it scans the ground and it looks for a flat area to be able to land. And so there's times where it's descending and then it pauses because it stops its descent to be able to calculate where am I going? Like, where am I going to land myself? Which is a common thing we see with landing on the moon, even back to Neil Armstrong, right? They overshot their landing site and then there were boulders everywhere. And it was very, very stressful, though apparently he was fine. His heart rate did spike a lot, though, but he came across as very calm. Now we have that automated, right? We have our spacecraft do this. This is similar technology that's used when we land, like Curiosity and Perseverance with their sky cranes, right? Like actively scanning the ground, identifying hazards, and navigating away from them. So that's where that image comes from. And that video is really worthwhile looking at if you can find it. The image on the top left is back from August 5th when it was in orbit. The spacecraft was in orbit around the moon. Just a very interesting look at the moon. We only ever see one side. And so it's awesome to see all these different faces and sides of the moon. And on the bottom right is the one image I was able to find of the rover as it was leaving the lander / on the lander platform. What was interesting about this is you think we've landed. All right, let's open the door. Let's drive the rover out. They can't do that right away. Gravity is different on the moon. And so all of the dust from the impact takes a much longer time to settle back onto the ground. And they don't want to expose their rover to that, right? Lunar regolith is actually sharp. Like we describe it as like this tiny dust. It's sharp dust. There's no wind or wet water to erode the edges. And so it's sharp. And it actually, NASA astronauts who went to the moon spoke about how it was very irritating and would actually wear away the joints in their spacesuits quite quickly. It's also electrostatically charged, so it sticks to you. It's not comfortable, and you don't want that on your spacecraft, and you certainly don't want it on a rover that's solar powered unless you have a blanket covering your solar panel, right? So they had to wait a while before actually sending out the rover for that dust to settle, which I thought was very interesting, and I honestly had not thought about until I read. And I was like, of course that would be a problem. You'd have to do that.
Yeah, I guess was that a problem that the Apollo astronauts discovered when they landed on the moon? I don't recall that they were talking about that because of course they were just excited to get onto the moon. But I do remember in the aftermath talking about how dangerous that dust was. But that dust cloud after it landed would have, I wonder how long it would have actually lasted.
It lasts. I guess it depends how fast you're landing and how hard you hit to send the dust up. But there were a few. I think it was. I don't want to get the name wrong. Jim Lovell, I think. He spoke about how when one of the guys who was on the moon, they spoke about how it stuck to their spacesuits. If you look at the old Apollo photographs, you'll notice that the legs of their suits are always quite gray. That's the dust sticking to them. And then they spoke about how when they got back into the lunar module, the ascent module to go back up to meet the orbiting spacecraft, as they lifted up, all of this dust would float into the air. And it would be, they tracked it in from their spacesuits and stuff. And it could be quite abrasive. The worry was that it would be very abrasive to the lungs, which is why in the new Artemis spacesuits, they have these special dust filtering in them so it can filter the dust out and keep it from getting into the spacesuit and into the joints of the spacesuit. I think at one point there were ideas of running a minor electric charge through the spacesuit to repel the dust, but I'm not sure if they're going ahead with that. But it's actually quite a large problem, more than we thought it was now, and more certainly than we thought it was during Apollo, because we didn't really know about it till we went.
Right.
It was very, very fascinating.
Well, this is very cool. If you were out there watching, if you have any questions about this amazing mission, India has landed on the moon with Chandrayaan-3. Get it in the chat. We've got 15 more minutes live here. And of course, we have another, we have more pictures here from the
ISRO.
ISRO, yes.
Yes, it's because, Indian Space Agency is kind of like the catch-all term, but it is like the Indian Space Research Organization.
Right.
So the acronym is ISRO. It's also it's something that happens all the time. But these are just more images. I love different views of the moon, specifically the craters and like the mare that you're seeing here and craters within the mare, just a completely different view than we're used to seeing of it, which is always fun.
Yeah, this is really fun because we developed not only a new planetarium show for the next season, but also a new live science demonstration show, which is all about going back to the moon. And we have our big flower pot that we are throwing rocks into and creating craters. And the kids have been having a great time creating craters and having a look at the shadows that are created as we move a flashlight across in the dark. And you get to see sort of those deep craters that actually are permanently shadowed. It's actually really neat.
It's very cool. I mean, none of these are shown, but it's very interesting. But yes, there was another huge success to the Indian Space Research Organization is Chandrayaan-3. I cannot emphasize enough how remarkable it is that they've landed on the moon. For anyone to land on the moon is a big deal. It's very hard, as we saw earlier this week. Before the Indian Space Agency landed, there was the Russian Space Agency was attempting to land Luna 25. So it was renamed, I know, 25, because it was actually renamed to Luna 25 to fall in line with their lunar program, which Luna 24 last launched August 9th, 1976. So we're really bringing it back. Really bringing it back. This is a artist interpretation. Yep. Okay. You said it. I didn't bring that up. This was an artist interpretation of what the Luna spacecraft kind of looks like. It was launched August 10th, so it got to the moon faster than the ISROs. They launched back in July because they, different decisions regarding fueling and the travel time and how they were going to get there. It also targeted the South Pole region of the moon. So for a minute there was a very it was a minor space race of who's going to land first, because technically Luna would have landed first. The problem, though, was that Luna crashed. So it did not make it to the surface in the way that the Russian Space Agency wanted it to. It crashed on August 19th after a technical glitch. What happened was that a command was sent to the lander, this was a lander as well, to move it into a pre-landing orbit, right? So it was around the moon, but they wanted to get it into the proper orbit so they could start to bring it down to land onto the surface of the moon. But the maneuvering engine, so the engine that burns fuel and pushes it into a new orbit, couldn't shut down. It didn't shut down properly. It was supposed to run for only 84 seconds, right? A very timed burn. All of this is done to the second, right? It needs to be incredibly precise. And instead it ran for 127 seconds, which is, twice as long, or not quite, but way too long. They don't want it to run that long. What that did is that it moved its orbit, instead of one that would orbit close to the surface, 18 kilometers away, minimum distance, into an orbit that intersected with the moon itself. And so they essentially pushed it into an orbit that forced it to crash into the surface of the moon. Right. And so it did not successfully make it down. Whoops. But had it, they would have been the first. It was with this crash then the ISRO ended up becoming the first space agency to land on the south pole of the moon. And the missions were kind of very similar, right? So Luna 25 was also going to study the composition of the lunar regolith. We're also planning to look at the plasma and dust of the exosphere. So the moon doesn't have an atmosphere the same way Earth does. It has a very, very thin atmosphere, so thin that we call it an exosphere. It's barely there. But it's still interesting to study. So they wanted to study it, but unfortunately are unable to. The Russian Space Agency does have plans, though, to launch Luna 26 and Luna 27, but currently those are just plans. There's no telling when they're going to launch and if they will even make it, if they are to launch them. And where Luna 25 was meant to go is actually a specific crater, which was nice because it was named on the map. The Boguslavsky crater is where they were trying to land, in and around the area, not necessarily in the crater. It just met their landing criteria. So when we send things to the moon, and we want to put them places. There's a list of criteria that we want to meet to have a successful landing, and based on what we want to study. So in this case, the location had to be between 70 and 85 degrees south and 0 to 60 degrees east if you're doing latitude and longitude due to engineering constraints. The surface had to be relatively smooth. That's kind of what you would do for all types of landing. And they specified it had to be boulder free, but a boulder was defined as something larger than 30 to 50 centimeters was considered a serious threat, which I thought was very funny. Like that, those size are just really bad. But they used the Lunar Reconnaissance Orbiter camera and the images that they took to create this map to help them chart out where they were going to land, which I thought was very cool because you're looking at the same map or one of the maps that these scientists would have used over at Roscosmos to help determine where they wanted to land. And to give you an idea of size, because the scale doesn't really show up very well on the image I have here, the crater inside this crater, so this is known as Boguslavsky D, it's pretty deep. The main crater itself is 97 kilometers across. Wow. So that is 97 kilometers and 3.4 kilometers deep. So they wouldn't land in the crater, but they land around it, right? Because if we're going to start sending people to and around the South Pole, where it's very heavily cratered, we have to get used to landing in and around them and navigating that terrain. So it was a lot of science being done in terms of how are we even going to land these things, let alone what science are we going to do once we've landed.
Yeah, wow. This is so amazing just to think about the moon in this way, as all these countries and all these missions are going to start to get human presence back to the moon. It hasn't happened yet, but we can certainly see it potentially happening in our lifetime. And I know you got the question, I certainly got the question when I was being interviewed back in 2019, is this a new space race? Seeing all these new countries go back to the moon. And I was kind of related to when we originally went. Of course, it did feel like a race because of the political climate. The political climate isn't exactly that much better. It is better, but not that great in terms of like some of the countries that we're talking about, right? So from your perspective, from just a science perspective, like, is it a new space race?
I mean, it's hard to call it a race when they crash, like there's a clear winner, right? If it's a race, there's a clear winner. I don't know, it's less of a race. Like in terms of Chandrayaan-3, right? They didn't work alone, right? The Indian Research Space Organization didn't work alone. Like the lander, the mission, the rover was all built, funded and built with ties to the Indian Space Research Organization. I know they recently opened up to allowing private funds involved as well, though I don't know the specifics of that. But they also had the help of the European Space Agency. A lot of the problems that happened with Chandrayaan-2, I think, were somewhat attributed to inefficient tracking systems and knowing where the spacecraft was, in addition to other problems. And so they got the help of the European Space Agency. So it was the European Space Agency who provided the technology and tracked the spacecraft so they could have a reliable knowledge of where the spacecraft was. And so it's not so much a race as it is just intense collaboration. I find like it's much more collaborative than it was back with like in the space race that people would think about, where it was one country's organization versus another country's organization. Now it's kind of a international push, like an international effort to get to this location, right? So like even with NASA's Artemis program, like Canada is very involved in that program, right? And with the whole idea of the Artemis Accords kind of lends itself to more of an international collaboration, regardless of how you feel about the Artemis Accords. There's some criticisms of it and the whole idea of them, but it does show that more countries are willing to work together to be able to get to the moon and this type of goal, as opposed to pushing against each other and trying to race. And I find that like when you race and you don't work together, you make a lot more mistakes, right? The whole idea of having multiple different agencies working together means you have a more diverse group of people working together, which lends itself to better problem solving anyway. So it just makes more sense for it to be more collaborative, which is why I'm glad to see the turn that it's kind of pushing in this way. It leads to better science at the end of it.
Yeah, it certainly seems that there are certain space agencies that you just named that are working together as part of the Artemis Accord. But has Russia signed this accord?
No, Russia actually pulled out. Russia refused to sign, citing too American-centric, which is not an unfair criticism. Like if you read through them, it is very much NASA's interpretation of what international scientific exploration should look like, right? Russia has a very different view of what that should be. China also, to my knowledge, has not signed on to the Artemis Accords. And so there is, some conflict, but on the whole, I find it's much more collaborative. It's not like we would never see the science that China or Russia would do on the moon. They still publish papers. We still see the science. Their scientists still go through the scientific process. It's just a step removed, I would say, from the countries that have signed on to the Artemis Accords.
Yeah, and I think it all plays into the big question of this next era of human space exploration, which I think also includes the Space Act and the Moon Act, as we continue to put humans out and start to involve humans in different endeavors, like commercially, whatever it's going to be, collaboratively working on solutions to the new problems that are going to arise, right?
Yeah.
And the moon, I guess, is sort of like the test place to work out these things. And that's very interesting to me. And just like seeing that there are allegiances happening and where conflicts are going to arise and how those conflicts are going to be solved between the countries, right?
Yeah.
China and India are countries that don't quite get along with each other. And then, of course, you have Russia and America right now. There are, it's not quite a Cold War, but there may be an incentive to work together if there is a way to collaborate. And that's, I think, what makes it different than in the 1960s, is that there is a financial incentive and there may actually be a benefit to these countries to collaborate. If they will or not is another story, because there's also companies that may not be associated with just one country, right? You have private corporations that are invested in many different countries.
Yes.
How that plays out will be very interesting as well.
No, the two environments where we're going to see a lot of like the newish field of space law, right, is what it's being called, is going to be the moon, and it's going to be Earth's orbit and satellite issues, I think, are going to start to rise. Who owns the space above a country? Does anyone own it? Are you allowed, because we have flight space, right? Airspace. Are we going to have space? Like that becomes a question. And then it'll also be the moon, what, because currently, as it stands, no one country can own the moon. We've all agreed upon that. But we're not just talking about the moon, we're talking about water in the moon or iron in the moon. And so it'll develop into a much larger conversation.
Yeah, very interesting. Well, I mean, it's certainly very exciting just to see all of these new countries doing things back on the moon. And like I said, I'm personally invested and very excited to see Chandrayaan-3 finally land. I give the honors of being interviewed on CBC to you this time, Marley. So
yeah.
Hopefully I didn't make fun of your shirt this time.
No, because I don't wear UFO shirts. Like I don't give people the option to make fun of me. I don't.
All right. Thank you to all of you that have been watching on YouTube or Facebook. Of course, if you have any questions about this episode, throw it into the comments. You can also email us on ours, or you can message us on our social media apps. There's lots going on. We are going to be back in 2 weeks. That is going to be on September the 7th after school starts. We are going to have, I know, right? We finally made it. We made it through
already.
Yeah. We are here. The weather is starting to cool down, which I am actually thankful for. But thank you to all of you. We hope to see you on September the 7th. Take care.